All right, everyone, I think my video kind of got kicked off. So we made our histogram, and then we want to find the percentage of between 52 and 55. So we're going to add 52, 53, 51. So 0.225 plus 0.2425 plus 0.1 equals 6575.75. And then what percent of hats is in the sample are below 56? Well, that's 100% because it's all of them. Skipping 63. This one, skip. So this is your homework, part 2. Four 4.3.2. We're gonna go to PDN. So we have a random sample of 35 cars taken from a rental NG. The highway mileage of each car was measured in miles per gallon. So between 24 and 27. I think we're not including this one, and including. So 27 is not included. 26. 25. 2. 27 to 20 to 30. 3. 30 to 33. Not including 33. 1. 33 to 36. 1. Not including 36. 2. 3. 4. 5. 36 to 39. 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 39, 42, 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. Last one. 1, just 10. Okay. Relative frequency, there are 1, 2, 3, 35 cars. So we have to do 2 divided by 35, 3 divided by 35, 1 divided by 35, 5 divided by 35, 13 divided by 35, 10 divided by 35, and then 1 divided by 35. And then you're going to construct your axes right there. Make sure you find the percentages. Two divided by 35, 3 divided by 35, 1 divided by 35, 5 divided by 35, 10 divided by 35, 13 divided by 35, 1 divided by 35. So 0.57, 0.57, 0.0856, 0.023, 295, 0.142, 13, 0.286, 10, 0.286, 0.371, and then 0.029. You're gonna plot those on here and then make your graph. Sorry they don't make out a nice like graph. Okay. 4.3.2. Normal probability. So we have some notes. We have norm PDF. That's the normal probability density function. It graphs a bell curve. And then on CDF is cumulative density function. And it gives the area under bell curve in a percent. So, for instance, it tells you that this percent is like 67% or something like that. Outside. All right, so 72. Charity race times. Reread problem 4.63 race times. Recreate the relative frequency histogram on your calculator and record the mean standard deviation. '63. Race times. Here we go. Siri tool open. Scroll down. Single variable. Okay. So here's the average. And then standard deviation. You want to choose. If you change the y-axis scale, there you go. And you can hit menu or 9, show normal. Now you calculate the model of the women's 5K times within normal normal distribution. I'm having a hard time. All right, everyone. So here is, I use the formula to type it in, and this is the normal curve. This is the normal curve, and then I'll give you the answer real quick. Then that's the normal curve over top. So it actually does a pretty good job modeling it. So most of your data is in the middle, and then it gets less and less as you spread out. 73. If you want to use a relative frequency history and determine the percentage of women in this sample, you have to have run times between 22.5 and 24.5. You would have to add up the bars between 22.5 and 24.5. But since your histogram is not drawn cumulatively with those bins, you'd have to redraw the histogram. However, your model of the data comes to the rescue. The area between 22.5 and 25.5 is shaded. You're right, using normal CDF function and calculator to find the relative frequency of the area between 22.5 and 24.5 in general in the Desmos calculator. So you're going to type in norm CDF. Let's see, functions, and you go to norm CDF. So distributions, norm, or I think it's just CDF. And then you're going to type in 22.5, comma, 24.5, comma, 23.2175, comma, 0.9729, enter. CDF should be called on a distribution. Functions. functions CDF 24.2.5, comma 24.5. Norm. Okay, everyone. So what you want to type in is this function button right here, normal distribution, and then you type in the mean and then the standard deviation, and then you check off cumulative probability, and then you type in 22.5 and 24.5. And that will get you your value of 0.676 or 67.6%. Your model represents the percentage of women in the sample who have various time run times, but it does not do much more than that. Since your sample of 49% of women represent the whole population of women who run 5K races, your model can tell you the percentage of women, the whole population, if your model represents the population percentage of women who run 5K races that have rates between 20 and 25. So essentially, you're going to do this document, same thing, and just change this. So this is from 20 to 25. And that gives you your shaded region. And that area is equal to the probability. So that's equal to 0.966 or 96.6%. So almost everyone. Although the fastest and smallest times in sample women was 20.6, the normal probability density function that you're using to model the population starts with a negative infinity and goes all the way to positive infinity. What percent of all women in the population run faster than 26 minutes according to your model? Since your calculator doesn't have infinity, key enter negative 9, 9. And this is where being on the left is actually good because that means you're running fast. So you're going to change this. They want faster than 26, is that right? 26. And then you do negative 10 caret 99. So that's like 99.7. What percentage of women in the sample run faster than the mean time? What percent of women in the population does the mean model will run faster than the mean time? So the model will be 50% because 50% is above the mean. And then for the data, it's 47.5. Because if you look at the data and you count the number of actual people. So it's pretty close. If you had more people, it would be better. 47. Advisors for runners part 2 is down comfort race 775 racers based on the model of your hat size distribution for all women. You need to order hats for the events. On your calculator, recreate the relative frequency histogram for 40 women with hat size problem in this. I think I have the picture. Use the mean and standard deviation. B. Using standard deviation has as calculating problem for one day model the data using the normal distribution. So X bar equals 53.3325 and S equals 1.1195. So if you, I'm not 100% sure how you get the histogram on top of the normal probability plot without having to type in all of the data. So I'm just going to give it to you again. On your homework, you can just have the histogram and then the bell curve separately. To do the bell curve, you have to use this gnarly formula. And this was 1.1192, 1.1192, 23.33, 53.3325 squared. And there it is. Here's your model. Determine the percentage of women who wear hat size 51. So that means you want to go from norm, CDF, and then you type in 53.33525, comma 1.1195, and then you want to do from 51 to 52. 3.3325, comma 1.1192, and you want to do from you want to do from 51, 52, and 0.98. 0.098. And then how does the percentage of hats calculate the proportion? How does the percentage predict the model? So you do that times 775 to get 76 hats. How many hats Size 51 hats does she buy? No. 76 hats. Use the model to predict how many racers at the style and comfort race are expected to have a hat size smaller than 51. So make this 51. And honestly, you could do 0, or you could do -9 E999. And you get 0.1. So 1.8%. And then you get the same answer. So how many racers do you expect to have a hat size of at least 56? So 775 times. What is about a size of at least 56? 56 to 10 carat 99. Just that percentage is super small. There's 0.0085, so about 0.01%. No, it's about 1% maybe. So times that by 7, so that's about 7 racers. What about hat size 51 to 55? $91.3. So that is 0.913 times 775, which equals 754. So G, does your answer in part E make sense when compared to the answer from part F? Yes, 14 racers size under size 51, 754 racers between 51 and 55, and 7 racers of size 55 or over 775 racers in all. So if you add them all up, 7 plus 14, so 14 plus 754, that equals 775. So what percentage of women does your normal distribution model predict hat sizes between the negative infinity and infinity? Should be 100%. All right. Here's part 3, 4.33. We're going to add a page here after this one. I think we talked about this. I can't remember. But this is the empirical rule. So if this is the average, and standard deviation 1, 2, 3, these are percents of the data that falls within their range. So within 868 is within 1 standard deviation, 95 is within 2, and 99.7 is within 3. So memorize that. be helpful. And two, the ACT is a test that colleges use to help make admissions decisions for potential students nationwide. Scores number distribution. What does it mean? Score 21 out of possible 36 and a standard score of 4.7. The model the scores of any test takers in your calculator using normal distribution. An appropriate value for the maximum relative frequency is 0.1. Normal distribution 21, comma 4.7. So there's your distribution. Adele scored 25 on SAT with your team score how well she has done. Remember, your normal distribution is a model for the bars of relative histogram. Shade the bars in the area under the normal distribution. She got a 26. So she's 26. And then you do from 0 is the lowest score. She scored about the 85th percentile. She scored 25. So she scored in about the 80th percentile, which means she did about better than 80% of people. Because 80% of the test takers have a score below Adele. And you can say Adele scored an 80th percentile. Remy scored a 16 on ACT. What's Remy's percentile? Sorry, Remy. The 14th percentile. Internet score on the ACT was without a calculator. Make a sketch of the scores below internets. This is 21, it's the mean. And half of it scored below. 50%. Percentiles are not just for normal distributions. They can fall for any set of data represent scores given that fall below a given score. Oh man, that's almost my name. Geometry. So make a histogram. Take the student E tool. Make histogram data with bin of 5. Latifa is a model in the data using normal distribution, but her partner Farid thinks that her is not a good one. What advice would you give them with using normal distribution? So no, because it is not normal. It is skewed left. Latifa scored 86 in the test. Farid scored 92. What percentile to each score in? So Latifa was the 20th score out of 80, out of 35. And then Farid was the 29th out of 35. So she's in the 57th percentile and he's in the 83rd percentile. How did I get 20th? I just counted the scores. Kind of annoying. See, estimate the 25th percentile and the 75th percentile. I don't need to estimate it. I can just do box plot. 69 and 90. What 5 numbers are min quartile for this? What is the min? So the min was 17. First quartile was 69, 80, 90, and 94. And 94. I just compared your answer in part D. It matches exactly. Sorry, I got kicked off. Matches exactly. Okay. Skip. So you need to go to studentdesmos.com and then type in this code, and then you're going to need to do 3 problems from the Desmos activity and insert a photo, please. So when you do it, it's going to look like this. It's going to look like this. And then you have to type in your response. And you can just do 3 of them. Doesn't matter which ones you do. Homework. Part 4. I think I might have missed the PDN, so here I'm going to do Thursday's PDN. Commercial cherry trees produce fruit according to a normal distribution of the average 90 kilograms per cherry tree, standard deviation 11. Sketch a normal distribution curve, label the axes under the curve. So this is 90, 111, 101, 112, 123, 79, 68, 57. What's the name of the normal curve? This curve, it's a bell curve or a normal curve. Based on your bell curve, what proportion of the trees fall between 79 and 101? So 79 and 101, that's 1 standard deviation above and below. So that's 68%. Based on your curve, 95% of the trees produce between, that's this, 2 standard deviations, so 68 and 112. So Fridays, continue from yesterday's one. What is the probability that trees produce at least 95 kilograms of cherries and use normal CDF? So normal distribution was 90 and then 11. And then the first one was at least 95. So 95. And then 10 carat 99. The next one was 85 to 105. And the reason why you have to use this is because it's not a perfect standard deviation above and below. And then what percentile of harvest is between, would a harvest of 80 kilograms for a single tree. So you want from negative 10.99 to 80. So the first one was 0.325 or 32.5%. This one was 59%, and this one was the 18th percentile. All right, last one. 4.4.1 and less than 1.2. And Joshua's parents tell him before his favorite tree has to be chopped down. He is devastated. He loved climbing that tree as a kid, and in it, he's built the best tree house. And one sad day, Joshua watches the Ahlers start to chop the tree down. The branches. When the tree branches cut, what does the cut of the service look like? Make a sketch. Make a sketch. Check with the team and everyone can explain what shape he drew. So if we cut a log, so if it's a circular branch, I think it's going to be a circle. One cross-section of branch below is too wide to fit in the chipper. One machine that grinds down branches into wood chips. So the logger cuts the branch lengthwise. What is the shape of the cross-section? So if you have your So if you cut this like that, it's gonna be a rectangle. Josh is surprised to finally see this tree trunk. He would have sworn the tree trunk was the shape of a cylinder. The picture shown on the right shows a cross section. Discuss with your teammates the shape of the tree trunk. So the trunk would have still mostly look like a cylinder because the abnormalities might have just been near the base. Encourage to convince each other that its strength in their visualization skills. I mean, it's just a little dense, so it's not like a perfect circle, but it should be a circle. 4-96. After a surprise of finding the heart with his favorite tree, Josh thinks about other interesting cross sections he might discover. He decided to cut an apple in different places, explore the different cross sections. If Josh makes a horizontal cut at each of the places, indicate what the cross section might look like. Because there's a little like gap here, it might look like this. Or this is the apple piece, and then the red is the skin, like a donut. There, it's going to be just a circle. And then the bottom, you might just have like 1, 2, 3, because the disconnected portions. Hawkins has a cube to get the cross sections. A square, so you can cut it like this. If you cut it like that, a rectangle that is not a square, could you cut it like this? A triangle? Maybe you could cut it like that. And then hexagon. This one was hard. This one took us a while last year. So I think if you put from the midpoint, so slice out a 45-degree from the top by making it. Slice a 45-degree angle. Slice a 45-degree angle to the top, making the cut around the midpoints of the two adjacent sides. I think if you go from here to here to here to there, to here to here to there, there's your hexagon. So you're cutting like at an angle against the face. If you don't believe me, there's one right there. 4-98. Visualize cross sections might merely seem like an interesting pastime, but cross sections are the art of 3D printers. 3D printers print objects, making them taking layers upon layers of cross sections. Below a 3 object with 3D printer lines are checkpoints for the cross section. For each object, sketch the cross section. And the really top one's going to be like a super small square or diamond. Then not so big. Coffee mug. And then this one is but then with a and down here with a bigger handle on the bottom one to the bottom, a solid face. That looks like it's going to be rounded like that. Big one of those. That part's a circle, a bigger circle, and then here it's going to be like an ellipse, and a partial ellipse. If you need help, go to YouTube and look up cross sections. Franken is so fidgety he can never stand still. Today his attraction is a small piece of spiral bound agenda. He spun it, punts around it as his teammate Bernie watches. She's suddenly struck by something interesting. The agenda book is a rectangle, but when he spins it, Bernice watches. But when he spins it, I don't see any rectangle. I don't even see anything flat. It's cool. Describe what Bernice is seeing. At first, he creates a cylinder with this. While the second will create a cylinder with a hole in it. Bernice thinks more about the object she's seeing when Frank revolves around the agenda book and wonders what. So it's like spinning. When these things more with objects, GC one finger evolves the agenda book. I wonder what would be the object if the object would be different if they're rotating a different way. First would be a cylinder. The second would be a ribbon with endpoints joined to make a loop, but there's no top or bottom. No, the cylinder. It's a cylinder, and then this one would be just like a cylinder going this way. Like, this is a cylinder going this way, or a cylinder going this way. Cylinder, and then cylinder. What if a triangle was rotated? I think it would make a cone. While two-dimensional objects is over an axis, it forms a three-dimensional solid called a solid revolution. Below the beginnings of two solid revolutions, one with a rectangle at each axis. This one's a cylinder. This is a cylinder with a hole. Below are two more situations. What's the difference between the two solids of revolution that would be produced? It should be a cylinder. And then the second would be more like a ribbon with endpoints making a loop. So it'd be like a ribbon. Skip. HW part 4. And this is all for next week. And then I'll post this on Google Classroom or Neo right now so you can look at it. If you have questions, come to office hours. Period 3, plan on coming to Monday's office hours just because I want to check in with everyone and get some information from y'all. Thanks.